As per your request,
This call is now being recorded.
as per discussion with HOD sir, you are having today only these two lectures, first lecture and second lectures, and after that you will get the holiday for the whole day. And from tomorrow onwards, we will continue with our regular schedule, whatever the lectures, practicals, or tutorials are there. So as per timetable, we will go from tomorrow onwards. Okay. So today only this is your last lecture. From after this, your lectures are not conducted. If you want to continue with the timetable, we will continue as per the timetable, no problem. But as per your request from your side, we have taken decision that to relieve you from the 11:30 onwards, that is after first two lectures. Okay.
Okay, go ahead. What else you have?
So we will start as I think we have
Okay,
completed
as far as
data
this,
transfer
is concerned, I
and
don't have any question
from the
to be asked in
arithmetic
this particular.
addition and subtraction instruction, right?
So with this, I want to give a message to
Yes,
all
sir.
of you. If you take
Okay.
the first question as an
So
opportunity, like she has taken, and she has explained very nicely what she has learned throughout the.
so we have to continue with the same,
Obviously, we will
that
not
is
have any question. Only one suggestion for Aarti. Put a
that is
focus
next
on
instruction related to that.
and learn all the steps.
See, in this
So
case,
that's all from my side. If Mahesh sir want to ask any question. No question.
hello, am I audible to you?
Yes, sir.
Okay.
All the student will face
Who
in
is
this question.
wishing to join?
Aarti ji, you
Prathamesh.
focus on third
Okay.
unit. This is this.
Okay.
Suggestion
So
I'm giving.
only these two instructions are available, that is addition and subtraction. After that, division multiplication instructions are not available for PIC 16F 877 microcontroller. So after these two, that is as a total four instructions for addition and subtraction, we will go for the AND operation, then OR operation, then XOR, then increment, decrement, and rotate left, rotate right, and complement. So these are the some logical instructions. So you try just note down the instructions, that is mnemonics are A and D and LW K. So whenever we use the letter L in the instruction, it will automatically consider whatever the operands are there, or simply we consider the number is there. K is a constant number. So it is nothing but your literal value or constant number. So constant value K, here we have considered K is a number, suppose 20, 02, 08, H. So it will be ANDed, logically ANDed with the content of working register, that is W. So and constant, that is number constant, whatever number is there, with W. W means content of W, and result will be stored at W. In this case, zero flag may be affected. Okay, number of cycles required. Okay, 1, like that. And after that, IOR, that is OR, again with literal value sum. And then same operation is there, ORed, content of W, that is working register, are ORed with the constant number or constant value K, and result will be stored at W. So after that, if you, sorry, I have missed that, that is and WF with F, and D is your destination bit. As we have already discussed, when D is equal to 0, result is stored at which register? Hello?
Either in W register or in file register.
So if D is equal to 0, then which result is stored at W or file? D is equal to
W.
0 असेल तर W, and D is equal to 1 असेल तर
File register.
okay. So same condition is there.
What do you mean by single function?
That is, when we consider D, that is flexibility in our result, where it is stored. In that case, we prefer like this. So F is your file register and W is your another register. So content will be ANDed, content will be ORed, content will be XORed with the file register and content of W register. Okay, so in this case, D plays an important role or vital role where we want to store the result. So as whenever this character or a symbol, we consider here symbol D, symbolic representation where D is equal to, actually here actual use of instruction, we cannot mention D. So we mention like add WF whatever the 100H comma 0. So when it is after comma 0 is there, result will be stored at W. After comma, if it is 1, then result will be automatically stored at file register. Okay. So D mentioning here is symbolic representation. It is not actual mean like that we are writing here D. D is equal to 1, D is equal to 0. Not mean like that. So we specifying a some symbolic representation like D. So we consider the result storage in a register, and here K is your constant number. Actually, I have discussed also that it is not mean like that we write here K and anywhere else above this we mention K is equal to 02H, K is equal to 10H, not like that. So K means constant number, add WF 20H comma 0. So 20 is your address, sorry, actual content constant value K added with or added with W, and result would be stored at W like this. Okay. So this is related to some AND operation similar to the OR operation, that is content constant value K will be ORed with W, constant value, sorry, not constant here, file registers. Okay, content of file register will be ORed with the W, that is content of W. Whenever we use the word W, that not actually W's content of W, or content loaded stored at W in W, like that. Okay, so OR register. After that XOR, same logical operations are there. Logical operations, for logical operations except complement, we have to use two operands. So in this case, W is one operand and one constant number or content loaded at file register. So these are the procedures to perform some logical operations like AND, OR, XOR. Same case is there, constant number and with file register. In case of file register, we go with the D bit, destination bit. Okay. So when the word K comes, no matter to mention the D, as whenever constant number is there and some literal value is there, that is K is your literal value. In that case, result will be automatically or by default loaded or stored at W only. So no change in that concept. So whenever we place with working register and some another file register, in that case, D comes in picture and you have to mention after comma either 0 or 1. So if it is 1, it is, if it is not mentioned that comma 1, then no problem, it will be automatically considered as a file register destination. But if you want to load at W, then mention 0 here. Okay, so default is 1 and it will be automatically loads the result at the F register for various operations. So this is additional facility or feature provided in PIC microcontroller to store the result at either source, either destination register. Okay, or instead of storing always or by default in W, we may change the result storage sequence or preference to the another register, that is file register. After that, increment. So here no necessary to use another operand, as increment the file register by 1 and result itself stored in the either W or that file register. So here again it is also possible to, after incrementing some file register content, the result will automatically loaded into W without using here W. So if we use like this comma 0 instead of D, mention 0. Similar case for decrement. After that, rotate left. F means file register, and after rotation you may change the destination register. So in case of first controller, that 8051, we are using for this purpose mostly accumulators, but here instead of using only W register, we may change the content with the help of some file registers. Okay. After that, rotate left, then rotate right, and then complement. So here complement means not get function. So whenever 1 is there, it will be converted into the 0. If 0 is there, it will be converted into the 1, like this. Okay. So here some symbolic representation is also there. So just write down this table. Okay. Write down.
सर जसे मायक्रो कंट्रोलर 805 मध्ये रोटेटचे दोन दोन इन्स्ट्रक्शन होते तसं इथे नाहीये, फक्त दोनच इन्स्ट्रक्शन आहेत, ते पण विथ कॅरीचे. सिम्पल नाही आहेत ना सर?
Your voice is not getting actually. Hello.
हॅलो सर.
Huh.
सर
Yes.
8051 मध्ये रोटेट लेफ्टचे दोन इन्स्ट्रक्शन होते, जसं की रोटेट
Through
लेफ्ट आणि
carry and without carry.
येस सर. तसं इथं
हाँ.
विदाउट कॅरीचे इन्स्ट्रक्शन नाही आहेत ना?
नहीं है. It is a type of reduced. So instructions are reduced. So we have to go with the carry only. And if you do not want to modify the contents, then you have to keep the status of carry flag before using rotate operation. Like if initially it is set and you want to that particular bit 0, in that case you should mention that is clear the carry flag and then use this rotate instruction. Or if you want to keep as it is, if it is 1, then you have to maintain that 1 as it is. Or earlier it is 0 carry but you needs 1, in that case also you should set the carry flag like this. So here no special instruction that is with carry or without carry. So it will always be with carry only or through carry only. So when we shift the total 8 bits, that is lower nibble to higher nibble like this. So in that case your carry flag automatically flush out, that is all 8 bits are uh, rotated and again it will comes to the carry bit as it is. Okay. So but if we want to shift or transfer the some 1 or 2 bits, okay, in that case your earlier position of the carry may be affected. But whenever we seen that in case of suppose keyboard interfacing with the 8051, okay, so in that case whether the key has been pressed or not, we see the suppose carry status. Okay, so in this case for checking the status of particular bit d7 d4 d3 d4 whatever is there, so in that case you should always working with the 8 bits only. So whatever the content belongs to C, it will be automatically or written by the content, suppose D7 or suppose D6 like that. So your uh, observing bit is carry, but actual or before that operation, whatever uh, status of carry is not identified. We see one example like this. Okay, we go with some Excel sheet. Okay. see, when suppose here D7, D6, D5, D4, D3, D2,
Yes,
D1,
yes, you are audible. You
D0.
go ahead.
Okay. So these are your the bits. Okay, and here we mention the carry. C or C only mentioning. We mention only the C. Okay, C is there. And when we talk about these bits, so earlier state carry suppose 1 and your bits are 1 1 0 0 1 1 1 0 like that, and you want to detect these bits whether these bits becomes 1 0 or particular bit. If you want to check the D5, suppose it is not like that, we have considered that we want to check the D5 bit. So in that case you should rotate these two bits first into the carry, and then next third operation is like this. So in that case first operation is RLF.
What are different layers?
RLF. Okay.
What are different layers
So
of IoT architecture and function associated with all those layers?
this is your initial status of the carry bit, and by mentioning the first rotate left operation, this one becomes or comes here. So we mention here in the same color, so it will be automatically comes to here, this one, and this is one. After that,
These are the types of software
if we mentioning
embedded
some
in
separate color,
platform or
we should mention here blue to blue, that same, and here suppose another color is there, we should mention like this.
what in ARM, what
Okay,
does
alternate
A
color
stands for? What is
or
the
only
ARM
these three
for
colors
meaning
we
of
choose, then we go with this. Okay, so see, when we come to first operation, that is rotate left,
What
so
is the
here
difference between them?
carry becomes this one, and these two bits or these all bits shifted here. Okay, so see, D7 bit position is comes into carry, and your carry bit status
What are operating modes
is
of Cortex
replaced
and
or going to the D0 bit like this.
upon reset
And
Cortex and
if you want to check the status of carry, so see, carry flag is there. So if it is 1, if you want to check this bit, in that case you check here whether carry is set or not. If not, you, as we have discussed, we want to check the D5 status, then next RLF, next operation. In that case, this one comes here, and remaining bits
which instructions are responsible
like
to
this,
put to the
and this
CPU,
becomes
controller,
D0 bit.
processor, Cortex
Okay,
and preprocessor.
so in this way again second operation is there, but here also we are not interested to get the status of D6. We are interested in getting the status of D5, whether it is 0 or 1. Again, you have to use
Roll number 13,
same.
Jadhav.
Here this bit comes here, and the remaining bits like this, whatever the bit is there, it will be coming here. So after these three operations, as we are knowing that we want to check the status of D5, that's why we are using the rotate left, as this is closer when we use the left operation, rotate left, as compared to the rotate right. So if we rotate right, then you have to perform 1 2 3 4 5, and sixth operation is your required operation. But in case of rotate left, your third operation is your required operation. But if you want to check the D1 or D0, then you simply go for rotate right operation. It is not mean like that always you go with the rotate left. No, here for convenience I have mentioned the C in the left side. If we use the rotate right, then we use carry as a position showing position indicator here, no problem. So Here it is not mentioned or meaning like that. The carry is always at the left hand side of the register, file register or working register. So see which operation is suitable or which instruction is suitable for you for performing your required task. For that, you should go with either left, either right operation. As I have mentioned that D5 is closer to the left operations. That's why I have mentioned on the rotate left operations. If D1 is there, D2 is there, or D0 is there, I may go with the rotate right. And for these two, choose as per your convenience or your choice. Here also, this is left is suitable and D3 right is suitable. Okay. So based on that condition, we are performing the various operations. Are you getting what I am saying?
Yes, sir.
Okay. So similar to rotate left, rotate right operation is there. So here carry comes. See here first operation, carry status is here, here, here. We are not interested further whatever the changes are there in this. So after third operation, whatever the initial bits are there, this is I think C na 100 1100 and E, right na? CE, binary number system. So what will be this 9 and I think D na? बरोबर आहे का बघा? If it is wrong, let me correct. 3 and हे काय B, 3B, 7. Whether it is correct, right or wrong?
करेक्ट आहे.
मी लिहिले म्हणजे बरोबरच असेल असं काही नाही, चुकीचं पण असू शकते, कधी कधी मुद्दाम पण होते चुकीचं. ओके सी आता बघा, ओरिजिनल नंबर तुमचा सीई होता, सीएच असेल, हेक्स व्हॅल्यू आपण कन्सिडर करूया, हेक्स व्हॅल्यू सी होता, पण मला आता इंटरेस्ट आहे फक्त याला D5 ला. मग याच्यानंतर काय झालं, फर्स्ट ऑपरेशन नंतर 9D झाली, सेकंड ऑपरेशन नंतर 3B झाली, थर्ड ऑपरेशन नंतर ती 7 झाली. आय डोंट केअर, ऍक्च्युली सीई आहे, कन्वर्ट काय झालं फायनली 7. मला तो नंतर ऍज इट इज कुठेतरी लोड असेल, तर मी काय करू शकतोय, तो परत लोड करू शकतोय ना व्हॅल्यू, ऑलरेडी कुठेतरी मी लोड करून ठेवली एखाद्या फाईल रजिस्टरमध्ये वेगळ्या, आणि तो परत पाहिजे त्यावेळेस आपण चेक करू शकतो, अगेन रिलोड द सेम कंटेंट. बट हिअर वी हॅव टू प्रिडिक्ट this number with the help of rotate left or rotate right operations. So in this case, if we want to check the single bit, then it is okay. But if we want to check the status of complete register, whether it is matched or not matched or any bit is changed, okay. So again, in this case, another option is there. You may perform some and or operations by knowing the results. So this is your standard. Suppose when this is 0 and all are ones or all are 0, like that, and if this bit changes by an number, so its or operation result is there, its and operation result is this much. So again you may compare these values also. Okay, so different ways are there for comparison purpose or using hex values, but here for sake of simplicity we follow the rotate operations for examining single bits. Okay, so after that, is it clear? So for similar operations for rotate right also. हे लिहिलेत का instructions?
नाही सर, लिहिते.
Yeah. Till now, I will take attendance. Huh? Okay, roll number 1. Give me attendance. Roll number 1. Absent. Roll number 2.
Yes, sir.
Okay. Roll number 3.
Present, sir.
4.
Present, sir.
Okay. 5.
Yes, sir.
Who is this? Roll number 5.
Yes, sir.
Okay. Roll number 6.
Yes, sir.
7.
Yes, sir.
8. 8. 9.
Yes, sir.
9. Okay. 10. 10 absent. 11.
Yes, sir.
12. 12. 4, 13.
Present, sir.
14.
Present, sir.
15.
Present, sir.
16.
Present.
17.
Present.
18.
Present, sir.
19.
Present, sir.
20.
Present.
21. 22.
Present.
22. Okay. 23.
Present.
24. 24. Absent. 25. 25. Absent. 26.
Present.
27.
Present, sir.
28.
Present, sir.
झालेत का कम्प्लीट लिहून झाले
Yes, sir. झालं.
ओके 29.
Present, sir.
30.
Present.
Okay, next attendance we will continue after some time. Okay, see, so after arithmetic operations, see some beat operations, that is we are working on some specific beat only.
Embedded platforms used in IoT.
Okay, so in this case the beat operations, that is
Talk about
changing the status of particular bit from
What
a
are the features of
register.
software?
So these are comes under the category of beat operations, like BCF. C means clear, B beat, C clear, and F is your file register. So BCF, FB. So which register is there? File register is there. So out of that file register, comma B. B is your beat number. B may vary from 0 to 7, like BCF
What is ARM?
port A,
What is ARM?
comma
ARM says
2.
classification.
So from port A, bit number 2 is cleared.
Operating
BCF
and sleep modes. These are the things you
PSW. 1 is there, comma 1. So from PSW position 1, that is we start with 0, 0, 1, 2, 3, 4, 5, 6, 7. So total 8. So whenever we mention B, that is 0, 1, 2, or 3, like that. So for that particular number bit is automatically cleared. Okay, so it is mentioned that 0 tends to F of B. Here F is your file register and B is your bit number. So if it is mentioned here 1, so actually bit number 1 means D1. Bit 0 means D0, D1, D2 up to D7. We consider the bits. Okay, and if we mention here 1, so D1 will be cleared from that particular file register, or if it is mentioned 7, 7th bit will be cleared. BSF, bit set flat. Okay, so here F is your file register and here the again bit number. So if we mention the yes, that is set, so it will be automatically set that particular bit only. It will not affect the remaining bits in the file register. Only specific or particular bit is affected. That is, it may set, or in earlier case it may clear. Okay, so these are the bit operations. And next, related to the program flow instructions, that is bit test. First is bit test file. Yes, that is skip, and C, that is clear. That is, if it is cleared, it means 0. And next is BTFSS, bit test file skip if set. हे टेस्टिंग साठी आहे. बिटचं पोझिशन काय आहे, जसं वरती आपण काय करतोय, आयदर सेट और क्लिअर करतोय बीटला. डायरेक्ट ऑपरेशन क्लिअर करणे किंवा सेट करतोय किंवा रिसेट करतोय, हे झालं डायरेक्ट ऑपरेशन. आता इथं काय आहे, डिपेंडन्सी आहे. बीटची काय आहे इथं, डिपेंडन्सी आहे. तर कशावरती डिपेंडंट आहेत हे, स्किप आणि पुढचं, जसं डीजे एनजेड म्हणत होतो आपण तसं. पुढं काय आहे, सी म्हणजे क्लिअर असेल तर कोण, फाईल रजिस्टरचं या नंबरचं बीट, म्हणजे PSW3, PSW7, PSW2, लाईक दॅट. म्हणजे आपल्याला काय करायचं इथं, चेक करायची, कंडिशन एक्झामाइन करायची. दॅट इज बीट टेस्ट स्किप इफ क्लिअर. कुठलं बीट क्लिअर असेल तर स्किप करायचे नेक्स्ट इन्स्ट्रक्शन. तर एफ ऑफ बी मधलं 3, फाईल रजिस्टर मधलं 3, फाईल रजिस्टर मधलं 1, व्हॉट एव्हर जे असेल ते आपण चेक करतो ना, की बाबा BOR सेट आहे की नाही पिकॉन मध्ये. BOR सेट झालाय की नाही, किती नंबरला आहे ते एक्झामाइन करायचं आणि इथं पिकॉन टाकायचं आणि इथं तो नंबर टाकायचा 1 or 2, लाईक दॅट. त्याच्यानुसार आपल्याला काय करायचं, चेक करायचं. बीट टेस्ट, कोणाचं बीट टेस्ट करायचंय, फाईल रजिस्टरचं. ओके, किती नंबरचं चेक करायचंय, कॉमा नंतर जे आहे ते बी. त्याच्यानुसार मग काय करतो आपण, स्किप इफ क्लिअर. स्किपचा अर्थ काय, या इन्स्ट्रक्शनच्या नंतरची जी इन्स्ट्रक्शन आहे एक, ती इन्स्ट्रक्शन स्किप केली जाईल. म्हणजे त्याच्याऐवजी नेक्स्ट टू नेक्स्ट इन्स्ट्रक्शनला जाईल प्रोग्राम काउंटर, जर हे बीट क्लिअर असेल तर या इन्स्ट्रक्शन नुसार. आणि जर क्लिअर नसेल तर रुटीन एक्झिक्युशन, परत नेक्स्ट इन्स्ट्रक्शन, परत नेक्स्ट नेक्स्ट नेक्स्ट, लाईक दॅट. ओके, जम्प इट एफ ऑफ बी इज इक्वल टू 0. ते बीट जर 0 असेल तर जम्प करायचंय. त्यांनी जम्पला ऍड्रेस दिलेला आहे, तिथं जम्प करायचंय जर क्लिअर असेल तर. सिमिलर टू दॅट, सेट असेल तर बीट टेस्ट स्किप इफ सेट. कुठलं बीट, हे बीट. सेट असेल तर स्किप करायचं, लाईक दिस. ओके, आता इथं 2 मशीन सायकल लागतील. 1 किंवा 2 का म्हटलंय, जर ही कंडिशन सॅटिस्फाय झाली तर ते जम्प करेल, तर त्याला 2 लागतील. नाही झाली तर रुटीनला जाईल, नेक्स्ट इन्स्ट्रक्शनला, त्यावेळेस 1 लागेल. याच्यामुळे काय झालं, तर आयदर 1 or 2 झालेलं आहे. सेम केस फॉर डिक्रीमेंट. डिक्रीमेंट फाईल रजिस्टर स्किप इफ 0. तो फाईल रजिस्टर आपण डिक्रीमेंट करत अगोदरपासूनच आलेला आहे आणि शेवटी 0 झाला तर स्किप करायचं, नाही तर परत एकदा डिक्रीमेंट करायचं. डिक्रीमेंट एफ स्किप इफ 0. डिक्रीमेंट करून जर तो 0 झाला असेल तर नेक्स्ट इन्स्ट्रक्शन स्किप करायची आणि 0 नसेल तर नेक्स्ट इन्स्ट्रक्शन एक्झिक्यूट करायची. तर ज्यावेळेस आपण ऍक्च्युअल प्रोग्राम करू त्यावेळेस तुमच्या आणखी क्लिअर होईल. फाईल -1 मीन्स डिक्रीमेंट बाय 1 अँड जम्प इफ झेड इज इक्वल टू 1, म्हणजे 0 नाही त्याच वेळी जम्प करायचे. 0 असेल तर मग रुटीन एक्झिक्युशन. ओके. आता नेक्स्ट काय, इन्क्रीमेंट. जसं डिक्रीमेंट आहे तसं इन्क्रीमेंट एफ स्किप इफ 0. स्किप इफ 0, 0 असेल तर ते स्किप करायची नेक्स्ट इन्स्ट्रक्शन, दॅट इज जम्प टू द लेबल मेन्शन दॅट. ओके. ह्या झाल्या तुमच्या टेस्टिंग वाल्या प्रोग्राम फ्लो कंट्रोल मध्ये टेस्टिंग. आणि त्याच्यानंतर जे आहे ते नॉर्मल मधले आहेत. गो टू प्लेन इन्स्ट्रक्शन आहे, जिथं लेबल दिलं असेल त्यांनी जायचं, तिथं कंडिशन अनालिसिस करायचे वगैरे काही नाही, डायरेक्ट ऍड्रेस गो टू. त्यानंतर कॉलला पण जसं की SGMP आपण करत होतो, अप डाऊन वॉट एव्हर, नेक्स्ट, हिअर, तसं ह्या 2 असतील, गो टू आणि कॉल असतील. त्यानंतर रिटर्न, सब रुटीन पासून आपल्याला रिटर्न यायचं असेल, ओके, डिले फंक्शन आहे किंवा एखादं इंटरप्ट फंक्शन आहे त्यातून परत मेनला जायचं, रिटर्न इन्स्ट्रक्शन. रिटर्न विथ लिटरल व्हॅल्यू, जर कॉन्स्टंट नंबरने आपल्याला रिटर्न करायचं असेल तर तिक नंबर काय घ्यायचं आहे, म्हणजे काय सब रुटीन एक्झिक्यूट करतोय त्यात तुमची W ची व्हॅल्यू चेंज झाली, 0 झाली किंवा चेंज झाली, ती परत पुढच्या ऑपरेशनसाठी तुम्हाला ओरिजिनल जी काहीतरी व्हॅल्यू पाहिजे, मग तिथं काय करायचं, रिटर्न LW K म्हणजे 20H 02H लाईक दॅट. ओके. त्यानंतर रिटर्न फाईल, रिटर्न फ्रॉम इंटरप्ट. आता इथं जो आहे, जर तुमचा इंटरप्ट ड्रिव्हन प्रोग्राम असेल तर तो IE केलं इथं, रिटर्न फाईल IE इंटरप्ट. मग इंटरप्ट मधून रिटर्न करण्यासाठी आपण फर्स्ट केसमध्ये काय करतो, रिटर्न RETI करत होतो ना, इन्स्टेड ऑफ RET वी गो विथ द RETI, रिटर्न फ्रॉम इंटरप्ट. हिअर इन्स्ट्रक्शन इज RETFIE. इथं फाईल पण कन्सिडर केलेला आहे, म्हणजे काही रजिस्टरचे जर तुम्हाला फक्त ऍड्रेस माहित असतील, लाईक इंटरप्ट टायमर ओव्हरफ्लो इंटरप्ट असेल, वॉचडॉग टायमरचा आहे, तर तुम्ही त्या प्रकारे पण इथं यूज करू शकता. अँड नेक्स्ट सम अदर इन्स्ट्रक्शन्स लाईक नो ऑपरेशन, CLR WDT. CLR मीन्स क्लिअर, अँड काय क्लिअर करायचं आहे, WDT इज नथिंग बट युअर वॉचडॉग टायमर. अँड लास्ट इन्स्ट्रक्शन इज स्लीप, दॅट इज controller goes into the standby mode, that is sleep mode. Internal process is going on, but normal operations are stopped, displays are off, like that. Okay, so you write these instructions. After that, I think we will go with the examples in the next lecture. So write down. So give me attendance for next, that is 31. 31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34, 34, absent. 35,
Present.
36, 36,
What, you can stop. What
36,
are the,
absent.
components
37,
of embedded system?
Present, sir.
38,
Yes, sir.
39,
Present, sir.
40,
Present, sir.
41, 41, Ajay, absent. 42,
Present.
42,
Present.
okay. 43, 44, Pradeep. 45, 45, 46, 46, Mayur.
That is PA,
47,
Zigbee, and Wi-Fi.
Present.
48, 48, 49, 49, Jayesh, absent. 50,
Present, sir. Hello. 49, sir.
okay. 50 is present. 50,
Present, sir.
51,
I'm asking characteristics and.
51,
You are talking
Absent. 52.
Go back.
Yes, sir.
One
Yes, sir.
Yes, yes. 53.
Present, sir.
54.
complete difference in between BLE.
54. Absent. 55.
Next, I think Amruta Kardoni, she's having some network
56.
Present, sir.
if she is
57.
there, she can,
Yes, sir.
Patil.
but I received
Yes, sir.
58. Okay. 58.
Present, sir.
59.
is having some different role number. The issue is
59.
number 18, Kharade Pragati.
60.
If Kharade Pragati is there, you have not
61.
on university portal of which the link is given by CC Inamdar sir.
61.
I
62.
got the name from Inamdar sir. You go back, you do the
61.
registration on the university link Kharade Pragati.
62.
I'm talking to you.
Kiran.
If she is there. I
63.
pathology.
Yes, sir.
Okay, good.
Okay. 64. Akshay.
It's, Amruta-
64.
Amruta ji,
I
tell
think
us
initially
what
he has joined,
preparation you have done for
but after that again left. Huh?
lockdown.
I will put absent. 64. 65.
Still we are not able
Present, sir.
to hear it.
66. 66. 67.
Present,
Okay.
sir.
68.
Not audible.
68. Absent. 69.
Yes, sir.
Okay. So have you completed these instructions?
No, sir.
Okay. Write down. So
You just take off.
tomorrow we will continue with the examples.
Take off your headphone.
So one correction is there in the third column.
Okay. Where?
सर
Which
जे
instruction?
आपण सर जे आपण गेल्या वेळेस म्हणजे गेल्या पेज मध्ये जे इन्स्ट्रक्शन घेतलेत ना त्याचे
हा.
आहेत सर म्हणजे ते म्हणजे जम्प ते सगळे आम्ही लिहून घेतलोय सर इथे पण तेच आहेत सर सगळे
समोर स्क्रीन वरती left.
म्हणजे
नाही, नाही.
अँड ऑर एफ माइंड
एक मिनिट, हा.
हा,
हा.
now
आता
you
इथं काय?
You go ahead.
अँड ऑर बरोबर.
येस सर
हा. इथं काय म्हणता तुम्ही?
हे जे आहेत ना हेच तिकडे कॉपी केलेले आहेत सर हे इन्स्ट्रक्शन आणि ऑपरेशन जे आहेत ना सर ऑपरेशन्स जे आहेत ते तिकडचे न देता डायरेक्टली ते कॉपी केलेले आहेत सर
नाही नाही मला कळलं नाहीये. ऑपरेशन मध्ये आता इथं बघा अँड मध्ये काय दिसतंय तुम्हाला? डब्ल्यू अँड विथ के, डब्ल्यू अँड विथ एस.
हा सर हे आणि जे डायरेक्टिंग प्रोग्राम फ्लोचे जे ऑपरेशन्स आहेत त्याच्यानंतरचे
हा.
स्लाइड्स हा हे जे आहेत ना
हा.
हे ॲज इट इज
हा 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 सॉरी सॉरी ते काय झालं याच्यातच तसं आलंय. तुम्ही इथं हे करेक्शन करा. सॉरी गो टू पासून ना.
हा सर
हा हा ओके सॉरी. इथं गो टू पासून फक्त लिहा गो टू ऍड्रेस एवढंच. हे नका करू. Or simply okay, you are able to write the specification na or not?
येस सर
Okay, go to means only that much sufficient, that is go to the address. So these are not useful here. I think wrong is there. This happens for these instructions 1, 2, 3, 4 and 5. Go to, call, return, return LW and return from the interrupt. Okay.
Sir, roll number 10 present.
नव्हतं का अगोदर?
नाही सर होते मग अशी फक्त ऑडिओ माईक ऑन करताना लेफ्ट झालं चुकून.
Okay.
Sir, 34 is present.
34. Okay. Anyone else?
24.
24.
24.
ओके. नवीन फीचर मध्ये गुगल मीटच्या अटेंडन्स मध्ये कोण किती वेळा लेफ्ट झालं, किती वेळा अटेंड केलं हे पण दिसतंय बरं का आता एक्सेल शीट मध्ये आम्हाला. हिअर सी. दिसतंय का तुम्हाला? हॅलो.
हो सर.
असं
हा. आता हे ड्युरेशन पण दिसतंय. 2 वेळा लेफ्ट व्हा, 3 वेळा सगळं येते याच्यामध्ये. जॉईन करून लगेच रोल नंबर एंटर करून जे जात होते ते 20 मिनिटं, 16 मिनिटं हे असं टाइमली येते, ते अपडेट होत राहते. ओके, सो लीव इट. So do not mention these specifications here. From go to instruction to return from the interrupt, remaining same.
सर उद्या लेक्चर्स होणार आहेत का? म्हणजे संडेला सुट्टी नाहीये का आज दिल्यामुळे?
नाही, उद्या सुट्टीच राहणार आहे तुम्हाला. मंडे मला सांगण्याचं हे झालं, थोडंसं कन्फ्युज झालं. मंडे पासून. Tomorrow is your regular weekly off, no issue. And project, what about that videos?
हा सर, मी सांगितलेत. आज संध्याकाळपर्यंत सेंड करतो सर.
Okay.
Completed sir.
Okay. If it is completed, then you may leave the meeting. No issues.
I'm asking about data rate in terms of.
Now lecture is over.
Mbps, how much data can be transmitted between the devices which making use of those technology. ठीक आहे. Complete comparison चा study करा आणि rejoin with the same link to answer the question. Comparison between Bluetooth BLE, RFID, ZigBee and the Wi-Fi.